Welcome and hello. This is a video tutorial on HEC ResSim, and in this lesson, I'm going to cover outlets, specifically uncontrolled outlets and controlled outlets in a dam. All right, what I have on the screen here is a reservoir network. It's got a couple junctions, a couple reaches, and a reservoir. We're ready to begin editing the reservoir. So I'm going to zoom in and select the pointer tool or the reservoir tool. Right click on the reservoir, click Edit Reservoir Properties. Here we have our familiar reservoir properties dialog box. And on the left, we see the reservoir is named Reservoir 1, the pool is named Pool, the dam is named Dam. I'm going to begin by right clicking on Dam to get a context menu, and I'm going to start with Uncontrolled Outlet. So I'll click on Uncontrolled Outlet, and it gives me an uncontrolled outlet right here. This could represent like a spillway or a weir, or the user manual defines an uncontrolled outlet can represent an ungated overflow spillway or any opening in the dam through which water can pass without impediment by a movable gate or panel. So uncontrolled outlets in ResSim can be added to dams, diverted outlets, or outlet groups. In this case, it's just part of a dam. I'm going to go ahead and rename this uncontrolled outlet to Weir 1. And just to demonstrate, I'm going to add a second uncontrolled outlet and rename that to Weir 2. Over in the right, we can define some of the uncontrolled outlet parameters, such as the outlet elevation. Weir coefficient and length is one option, and then elevation versus outflow is the second option. With both of these options, we still have to enter in the outlet elevation. If we choose elevation versus outflow, then we can type in our elevation versus outflow values, or we can paste them in. I've got a few values saved over in Excel, and I'm going to copy and then paste those values in, and then click Apply. Over on the right, we do see a little diagram showing that relationship between outflow and elevation for Weir 2, which is an uncontrolled outlet. Also, I want to make a mention that this outlet elevation, which is 1468.5, needs to match the first elevation in the table, which corresponds to a zero outflow. And each row below that would be increasing elevations and increasing outflows. Next, I want to add some controlled outlets. And before I do that, I want to actually combine my controlled outlets into an outlet group. So I'm first going to right click on dam and then click add outlet group. And then with that outlet group, I'm actually going to go ahead and rename it. I'll call it outlet tower 1 for identification. And I'm stealing some of the terms and names used in the user's manual because I think they're more realistic and pretty good. Now I'm going to right click on outlet tower and add a few controlled outlets to that outlet group. So controlled outlet, controlled outlet, controlled outlet. Now I'm going to give them some names. We'll go ahead and make edits to our main gates controlled outlet. Over here on the right, we see a table of data for us to define the values of max capacity with elevation of the pool. This is the reservoir pool. I like to call the water surface elevation up in the reservoir, and also the number of gates. Before that, let me just draw your attention to the bottom right. There's this button called Edit Gate Settings, and by default, um, the first radio button here is selected that says specify maximum capacity only. So that corresponds to the table we're looking at here. And I'll go ahead and fill this in, but we'll return to show that other radio button option and what that looks like. And we'll stick with just a 1 here. So instead of typing all the numbers in, I could do that, but I got them saved here. and paste. So we have at increasing elevations, we have increasing max capacity. And this far right column here is total max capacity, but that's just simply a multiplier between the max capacity and the number of gates. So if I change this 1 to a 2, then the total max capacity becomes 2. If I change it to a 3, it triples and so on. So that's how that works. Also down at the bottom, there are controls to specify the rate max of increase and decrease of the gates and how fast they can open or shut. And the user's manual actually recommends leaving these values blank because these could be controlled later in the other parts of the model using the rules. Back to this edit gate setting button. If we click on this, like I mentioned, the default is just totally open or totally closed. But if we specify different gate openings, this represents opening a gate part of the way. So maybe it's just 50% of the way the gate's open, or cranks is the term used. We can also specify the percent or the length. So if it's length, and for instance, we have 3 gate settings, it may just be closed, and then a 6-foot gate may be halfway open at 3 and then fully open at 6. So if I go ahead and click OK, my table looks different here. The table shows elevation, but now it also shows specific flow rates for each opening of the gate based on each elevation. What that might look like for table data is this right here. And let me change the number of gates back to 1. In the graph, we have a vertical blue line that represents a closed gate, 0 flow. And then the red line in the plot here, I don't know how well you can see it, but it represents the gate is 3 feet open and then 6 feet open. And then if I change the number of gates here at the top to 2 or to 3, you would see the numbers updated here in the far right column representing the total max capacity. That's it for this video. It's we just talked about the different controlled outlets and uncontrolled outlets as elements that are part of a dam that are part of a reservoir.